Welcome to the DIY Honda Garage channel. The DTC P0182 refers to a problem detected in the fuel temperature sensor circuit, indicating a low voltage scenario. This issue is critical in ensuring the engine is running efficiently, as the fuel temperature sensor plays a vital role in monitoring the fuel temperature, allowing the engine control unit, ECU, to adjust fuel mixture and improve performance. Located near the fuel rail, the sensor's readings are essential for optimizing the fuel injection system. A malfunction here can lead to poor engine performance, reduced fuel efficiency, or potential engine damage. Before proceeding with the troubleshooting steps, it is imperative to record any available freeze data and onboard snapshots for comprehensive diagnostic analysis. The fuel temperature sensor plays a pivotal role by measuring the temperature of the fuel entering the engine. This measurement helps the engine control module, ECM, make necessary adjustments to the fuel mixture for optimal combustion. The sensor is typically located around the fuel rail area. Understanding its location is crucial for troubleshooting. If the sensor provides incorrect temperature readings due to low voltage, this can lead to performance issues like rough idling or stalling. Moreover, the low voltage condition may signal an underlying issue with wiring or connectors, which must be addressed to restore functionality. Several potential causes may lead to DTC P0182. A faulty fuel temperature sensor itself may be unable to provide correct inputs due to internal failure. Wiring issues could include short circuits or damaged insulation that could lead to low voltage readings. Poor connections, either at the sensor or the powertrain control module, PCM, can disrupt signal transmission, causing this DTC to trigger. Such conditions necessitate thorough investigation to isolate the specific cause. Checking each component and connection methodically can help achieve accurate diagnostics, ensuring a targeted approach to repairs. Drivers may notice several symptoms when DTC P0182 is present. The most immediate warning is the check engine light illuminating on the dashboard, indicating an issue that requires attention. This fault often correlates with poor fuel economy, as the engine struggles to adjust to incorrect fuel mixing. Additionally, customers may experience rough engine idle or performance inconsistencies while driving. Identifying these symptoms is key to a comprehensive diagnosis process. Awareness of engine performance can help narrow down the fault's origin, allowing for quicker resolutions. To initiate troubleshooting for DTC P0182, begin by turning the ignition switch to the on/to position. This action powers the vehicle's electrical systems without starting the engine, allowing diagnostic procedures to take place. Next, utilize the Honda Diagnostic System, HDS, to monitor the fuel temperature sensor data. You are looking for specific readings, an indication of 356 degrees Fahrenheit, 180 degrees Celsius or higher, or a low value of 0.08 volts or less will signal a failure. If these conditions are met, it confirms the presence of a fault, and you should proceed to step 2 in the troubleshooting guide. Alternatively, if readings are normal during this check, you might be dealing with an intermittent issue, prompting investigations into connections or terminals. For step 2, ensure that the ignition switch is turned to the lock 0 position to safely work on the vehicle's electrical system. Following this, disconnect the fuel temperature sensor 2P connector. After disconnection, turn the ignition back to the on/to position. Again, utilize the HDS to observe the fuel temperature sensor readings. If the observed values are 356 degrees Fahrenheit, 180 Celsius or above, or 0.08 volts or less, it indicates that the sensor has malfunctioned, and replacing it is the next step. Make sure to follow this through to ensure that the sensor is tested accurately and comprehensively before deciding on further actions. In Step 3, turn the ignition switch to lock, 0 for safety. It's now time to jump the SCS Service Checklist System line with the HDS. After this, disconnect the PCM connector B, which has 49 pins or positions, in preparation for the continuity check. To execute this check, confirm continuity between test points defined in the diagnostic guide. Test point 1 should correspond to the fuel temperature sensor 2P connector at pin number 1 with a green-red wire color coding. Meanwhile, test point 2 serves as a direct connection to body ground. Establishing continuity here is critical. If continuity exists, a short in the TF2 green-red wire must be repaired. If no continuity appears, further actions must be taken, including PCMs or software checks. Upon completion of repairs, it is crucial to conduct a verification process to confirm that the DTC P0182 is resolved. Start by turning the ignition switch to lock, 0, and reconnect all connectors that were previously disconnected. Following the reconnection, switch the ignition to the on position. Utilize the HDS to reset the PCM, powertrain control module, and perform an idle learn procedure to recalibrate the engine's idle settings. Finally, check for any pending or confirmed DTCs. If DTC P0182 persists, it indicates that further inspection for poor connections or the possibility of a faulty PCM may be necessary at this point. Otherwise, successful verification signals the completion of repairs. In summary, properly diagnosing DTC P0182 involves a series of systematic steps focused on verifying the fuel temperature sensor and its circuit's integrity. Each step plays a pivotal role in ensuring that all potential faults are addressed thoroughly. It's essential to utilize diagnostic tools effectively, such as the HDS, and maintain careful documentation of observations and changes throughout the process. If any other DTCs emerge, they must be tackled separately, but the principles of clear and logical troubleshooting should always be applied. By addressing possible faults efficiently, you can ensure the longevity and reliability of the vehicle's engine performance, keeping it in optimal working condition. Please like and subscribe to the channel. See you next time!